Hello. So we are live. I see the button has turned red. Great. Hey, Ally, how you doing?
Good. How are you, Chad? This has kind of been a long time in the making, so excited to be here.
It has, yeah. In fact, this stream has been a long time in the making, and what we're talking about has been a long time in the making as well, right?
Definitely, definitely. So we met, I think, last July. We were just talking about this in Paris at one of your Blue Yard events when we were just starting to talk about the Filecoin virtual machine then. So yeah, really exciting that we've come so far since then. We're like live on mainnet now, so really
Yeah.
cool.
So what work you're in Australia, right?
Yeah. Could you tell from the accent?
Well, I was guessing either somewhere in Australia or maybe like Austin, Texas. It's hard to know, you know.
Well, they do have AUS on them. I kind of got confused whenever I went to Austin. I'm like, I'm not going to Australia. Where am I? And then I saw the guitars, and I'm like, oh yeah, Austin.
Yeah.
No, I am based in Melbourne, Australia, but I spent most of last year on the road, meeting a lot of really cool folks like yourself and other people in the ecosystem. I've seen you've done a stream with Fission as well. Amazing team, love them. They're great. So meeting people across the Filecoin and Ethereum ecosystems was just like a really great year last year for getting my feet wet with that. And this year I've kind of settled down a little bit and I'm doing some more maybe dev work and project work rather than events and hackathons. So
Cool.
a bit of a switch there.
Great. I know that probably is a welcome respite, both in terms of the travel and in terms of being able to do development work.
Yeah, and it's just so far from Australia. So, 17, 18-hour flights to do anything. So, yeah, it's kind of crazy. I read a lot of books on Audible on planes and airports last year, though, which was kind of fun.
So what do you want to show today then?
Yeah, so we've launched the Filecoin virtual machine now. I was, as you might know, so it's live on mainnet. It's fully Ethereum compatible for those that might not maybe know the ecosystem yet. So what this means is, or at least the idea behind it is, Filecoin is a storage blockchain, or was designed to be a storage blockchain, but we've kind of got a vision to be like kind of far more than that. We want to be the decentralized internet, really, or we want to provide the infrastructure for the decentralized internet. So part of that is enabling kind of this compute over state. So this virtual machine that you might be able to generate or interact with metadata. So one use case, for example, is like data DAOs. You can all of a sudden start tokenizing data sets. You can decide who has access to them. You can decide what they're worth, if they're valuable. And I think that's like kind of a really cool model. But another tier of being able to provide the decentralized kind of internet infrastructure is, how do we then compute over that state? Clouds, you immediately have a serverless function. You can, get analysis. You can get AI these days. You can get pretty much anything through your cloud server. So one of the projects that I've recently been working on is called Bakuyao, which is this decentralized compute over data kind of platform. So a peer-to-peer network of nodes that compute over data. Yep. And Project Lilypad, which, thanks for sharing this one, that link, is actually an interaction bridge, we're calling it, although a lot of people kind of think tokens when you say bridge. So we need a new name. Someone's going to have to suggest one in the comments maybe. But it's kind of a bridge between a smart contract and this decentralized compute platform called Bakuyao. So we're really kind of trying to provide all the functionality. And this is just a proof of concept at the moment, but we will be, building it out this year. So you kind of get things like being able to compute decentralized AI on, this Bakuyao project and interact with your smart contracts as well. So I think that makes sense. And I've got a couple of projects that can kind of, I can show you some examples on too.
Cool. Should I share your screen then?
Yeah, well, let's share the screen. Sounds good.
There we are.
So actually what we're seeing here is just really like I built this as a demo for people when just before Filecoin Virtual Machine went to mainnet. We had a massive hackathon with ETH Global. Love those guys. They do a great job of hackathons. And I kind of built this example as part of that that would show kind of the capability of interacting with, you can deploy all your EVM contracts like an NFT contract, an ERC 721 in this case. And I'm kind of generating this image with a stable diffusion Python script that is run on the Bakuya platform. So maybe I'll show you kind of how it works. And this one really only interacts with a HTTP endpoint. So we've created like this HTTP endpoint for Bakuya, and I'm just calling that in this one. But we took it one step further with Lilypad afterwards. And I have to, so I'm going to create a rainbow unicorn. Obviously, I've created a lot of rainbow unicorns previously. It's become like my default prompt these days, but like I love the results. Although it's really funny, we kept getting 2 horns. Like you used to get 6 fingers in the stable diffusion models. And so, we're, jokingly like, kudos go out in rainbow duo corns to the team now.
Nice.
But yeah, so this basically what's happening here is I've called a HTTP endpoint that goes to Bakuya. Bakuya will accept that job and send it to a node. Now, because Stable Diffusion requires GPU, and we've actually only got one GPU node live on this network at the moment. This can sometimes take a little while, but obviously we'll scale that up in future. This is just where we're at currently. So this is running on a GPU-enabled Bakuya node, and it will return the results as an IPFS CID. So we're adding that kind of verifiability layer to your decentralized compute over data, I guess you would call it, which, funny story, compute over data, that's an acronym for COD. And Bakuya, the name, is, Portuguese for smoked cod. So tenuous links, fun story. Hard to say word. Took me forever to get it right. But for all the Portuguese out there, that's you would have.
I won't tell you how I pronounced it until I realized it was a Portuguese word. And that made sense. So tell me, if we can step back a little bit. So you said you have Filecoin, or sorry, the FVM or the FEVM. What's the right thing to call it now?
I guess currently it's FEVM, which just means there's an actor that's specific to the EVM runtime. The underlying FVM is actually built in Rust and on Wasm. I don't know why this is.
So it's sort of like there's a layer. There's the FVM layer. There's the FEVM layer on top of it, which adds the Ethereum compatibility.
Yeah, so it's super modular like that. So we could build out a bunch of different kind of layers. You could do, maybe I don't know, insert other chain name layer compatibility here as well. Obviously, the Ethereum network, everyone knows it. It's got a bunch of really great tools, hard hat, remix, like so many things that are being built up around it and make it really easy for developers to build on. And, obviously set contracts that have been audited that are out there, and, which is what I'm using here. So there we go, by the way. So yes, so FEVM is the Ethereum compatible version of FVM. And now they're working on building, the native version, which is that Rustbert version, and building that out natively with all the functionality too. So yeah, long-winded way to say that. I don't know why this is not showing up. I think it's because I'm like connected to my local host. I was trying to make it quicker for you, but instead I've broken it. So
well, that's what happens when we demo. Can I ask you a few more questions about things you already said?
Definitely.
Not sure if you need time to look into this, but I love that every video I ever see of you doing coding, you've got the console open with logs going by the way.
I mean, how else do you know what's going on, quite frankly?
I kind of leave mine open while I'm browsing the web too, and just see what kind of mess the various sites are spewing. It's amazing how many errors there are on sites you use every day. It's like, actually, there's always an error. Yeah. So okay, clarifying questions for you.
Feature.
So
let me just look up this. Sorry, I would love some questions. Let me just look up. So this is what got returned from Bakuya here. I just want to kind of prove it's right. Now I'm running this through Brave, which has IPFS integration inbuilt into it. So you don't need to go through a HTTP gateway to get the IPFS link, just in case anyone was interested in what happened there. And this is kind of what comes back from Backyao. So you have your outputs from whatever script you had. So it could be a Docker image or a Docker job, or a WASM image that's run on Backyao, which, makes it super flexible. And this is what we've gotten back if we have a look in outputs. There's our rainbow unicorn. So just on a basic Python, open source, TensorFlow, Stable Diffusion script. So pretty cool. And let's get to these questions now. Sorry.
Okay. So we have the FVM, we have FEVM, and you said that this is compute over state.
Yes.
And then you talked about Bacalhau being compute over data or data, or however we're going to pronounce it. I grew up in England, so I use data and data interchangeably. I sort of swap back and forth, and there are more. But so, what does compute over state mean here specifically?
So if you think about what you do in even Ethereum, compute over state is kind of, you change your variables in your smart contract, you change, you can do some minor computations on that. You don't really want to be building in, particularly something like a whole Python script into Ethereum. Like, I can't imagine the cost of running that on the Ethereum network. And it's just really inefficient as well. Like, you're running on multiple nodes. It really wasn't designed to do that sort of thing. Like, blockchain has like amazing features. I mean, we all I love blockchain or we wouldn't be here. And, it has some really great functionality, but because of its decentralized nature, like, it's not very good at, running these large kind of jobs, which is what we're looking for if we want to build out, the decentralized internet of the future. So, what was the question? Did I answer that, or just go on another tangent?
Yeah, the question was basically, what does state versus data mean in this case?
Yeah. Yeah, so state, I guess I kind of think of it like you're working over the metadata of things rather than interacting with or necessarily like scripting the underlying data. I'm not sure that that's a very good explanation, but
I think it is. Yeah. So if we're talking about an image, the metadata about the image in this case, it wouldn't be necessarily the size and the stuff that we think of as metadata. Naturally, it would be particular to the application we're building, I assume.
Yeah,
and it would be like who owns the image, for example.
Yeah, totally. And if you think about it in terms of maybe the Filecoin ecosystem, I was just wondering if I had a quick slide on that somewhere. Like, yeah, there we go. I do. So I thought about this before, so I'll show that for everyone. But yeah, if we think about kind of the Filecoin ecosystem, like, the layer 0 of Filecoin is really that storage layer. That was, the big thing that we wanted to get right to start with. How do we do decentralized storage, make sure it's scalable, like internet scalable, make sure it's verifiable, make sure it's getting stored, and give you the choice over how long you want to store that as well and renew those deals. And then, we've introduced this computation over state, which, for example, you wouldn't be pulling out like big files from your Filecoin storage and computing over them. What you're doing is looking at, for example, maybe how many storage deals have been made. That's kind of the metadata of the Filecoin ecosystem, and then doing things with that, like creating reputation layers or creating data DAOs where you can then, link to that verifiable piece of data that's stored in Filecoin, for example. So maybe that's a good way to think about it. And then the computation over data, which is really an off-chain functionality, but that we're doing in a verified and peer-to-peer way with Backyao, is, giving that rich layer of computation, giving analytics, giving, AI functionality if you want to do it, giving even big database interactions, things like that, I guess. Hopefully that's, maybe a better explanation there.
Yeah, that clarifies it really well. Thanks. And is Bacalhau coupled with Filecoin in any way, or is it a separate project that just integrates well?
It is a Protocol Labs project, so incubated at Protocol Labs. David Aronchik is the head of Backyao. He also was one of the leads of when Kubernetes first came out. He was working at Google and was one of the lead technical people that got Kubernetes out. So he knows his stuff when it comes to, you know, this data side of and containerization piece of the action. And he's created Bakuya here. So it is a Protocol Labs project. It runs off, so you can have your data stored in IPFS, and Bakuya can interact with that. And soon, you know, at some point, we also want to be able to compute over Filecoin data as well. There does need to be maybe some improvements in the Filecoin API, which is already happening thanks to FEVM, to be able to do that. But, you know, as soon as that happens, then, you know, there's the potential to then compute over data that's stored on Filecoin, which will be really powerful as well.
Cool, thank you. Okay, so you generated the unicorn.
I did. So, whoop, that's the wrong one. Yeah, by the way, so this is like all in our docs. If you do want to kind of create this Docker script yourself, you can go to docs.bakuya.org, and, you know, there's a full thing on how to create this text to image script for yourself, which was really cool when I first looked at it. I'm like, oh, I'm an AI developer now. But it's like there's so many tools out there to be able to do that, which is great. So I've generated that image, and then I can mint it out as an NFT. And this is when I kind of started thinking, and I did this demo project. I was halfway through it, and I'm like, I'm not sure I like really am on board with creating NFTs out of AI generated art. And I think there's like a lot of whispers of that around the ecosystem as well. It's like, well, what's this, you know, what are these models trained off? Where did those data sets come from? And the answer is they were really scraped from the web. So who knows if they're really public data. And so as part of that, we kind of thought, well, how about we build something out? We've got blockchain, right? We've got payments. We can give royalties to the original creators. So what we've actually just built out, and it's actually released to the Filecoin mainnet, is Waterlily, which uses Lilypad, the actual platform, rather than the HTTP endpoint. And what Waterlily.ai does is we've trained models based off artist data or public commons data we started with, just because, you know, you need to get artists on board, and do they want to be on board? It's really, you know, a personal choice for them. So we've trained this data off different artists. So for example, these are some public commons artists we've trained off, or we also have a couple of private artists. So Carrie Chen, she is awesome, by the way. If you haven't heard of her, she gave us a bunch of stills from a video, and it's actually it turns out surprisingly well. But anyway, so we've trained models based off their art and in their style. And every time a user comes on and generates an AI art image, we pay a like micropayment to this artist. In fact, we're not taking any money apart from the gas costs to run this. Everything goes to the artist or to a foundational partner. We're working with Creative Commons, so we're donating any of the funds from public images to the Creative Commons network, or we will be. So I'm like, this is kind of a new paradigm for how we might build ethical AI art that we've like, you know, as a proof of concept. So kind of exciting here. Yeah. Any thoughts on that? Can I explain anything there?
I don't know if I have a question, but it's really cool. I will restate what I think you're saying is, like, if I were an artist and I had, I don't know where artists put their work, you know, some portfolio site, you could take all the same stuff and upload it to train a new model so that someone could mint stuff. Yeah, I mean, it's interesting because this is one of those cases where during the bull markets, you see a lot of projects that are built where it's just like, here's the Web3 version of this or that, you know, the tokenized version of this or that. But here you're actually solving a problem that artists have. So beautiful. I'm not an artist, not a visual artist. I am a musician, and even the idea of eventually being able to do that sort of thing with music is really appealing. It's cool.
Yeah, 100%. Yeah, you could. And, you know, I've seen, you're speaking of music as well, I've seen a couple of people post, or that are rappers and developer relations advocates, people out there might know who I'm talking about, and they've posted, you know, just these videos of people making deep fakes, you know, sounding like exactly like Kanye West, and it's not at all him. And it's like, well, how do you verify that who's the original? Where's the original song? How are we going to verify this? And to me, like, there's only really one answer to that. How are you going to prove that you were the original creator of something? I mean, I'll let the viewers guess what the answer is. So yeah, but like what I do really love about Waterlily is the fact that, and I'm not an artist either, but what I do love about it is that this is giving a revenue stream kind of beyond NFTs, which are on certain platforms. Who knows if you're going to get royalties or not? And it's also, people are probably going to use your work in AI in the next few years. I think, you know, it's already everywhere. This is crazy development speed. Like, you know, I look at it and I'm like, everyone is. This is why it's such a hype at the moment, because it's just everywhere. It's really reached mass adoption, hasn't it? And it's just like, well, how do we make sure that there is some good happening here as well, and we're not just kind of entering this bubble of the only new things created from AI. Right. So we do need to create revenues for people, and, you know, hopefully maybe this is one small way that you possibly could do it as a proof of concept. Of course, I'm not solving the whole industry. Did you want to see how this one works, or have a look at the contracts? Or
yes, please, let's just walk through the whole thing as much as you're interested in showing.
Yeah, sure. I mean, I have all the code here. So what should we show you exactly?
What is this editor?
This is VS Code. It's just got a fun theme on it.
Oh, nice.
So yeah, just VS Code though. So this is all written in TypeScript. It's all on our repo as well, so you can go through and pretty much copy this. One thing we have done here though is we've created a private Bacalhau cluster to run this, because, you know, you're supposed to be paying for this work. We don't want just anyone accessing these Solidity contracts and being able to just, you know, get around the fact that you should be paying for the original artist's work. So we have kind of created this private Bacalhau cluster, and we ensure that jobs run from here have to come from our contract, just to try and lock that down a bit. But one thing I am working on as well at the moment is we've just created a automated pipeline for the ML models. And I should give a shout out to Richard from Algovera. I don't know if you've heard of Algovera, or if I'm saying that right. Just pretend it's the Australian way if it's not. So he created these this ML training models for us. Super smart guy. I think he's got a Twitter podcast coming up with Metallic Buterin, so that'd be really fun to see, or, you know, look back on if it's already happened. Talking all things AI. But he's created these models for us. And basically what we're doing is they run on Bacalhau, these weighted models. So we have an identifier and weights associated with each of the artists. And what happens when someone presses, say, maybe I'll just refresh this page so we can get the original page without the generated images already. My internet's a bit slow, but there we go. So when you first come to the page, you should see something like this. You'll put a prompt in and choose an artist. So let's say I choose Carrie Chan, and then, you know, obviously use the same prompt all the time. Maybe you choose a prompt, Chad. What would you like to see?
Deep sea jellyfish.
Deep sea jellyfish. I love it. All right, let's have a look. See what we get from... I might go with a different one. Carrie Chan can sometimes, because we've generated them from video stills, it gets some cool effects, but sometimes you can't always tell what it is. So I'll just choose a different one here.
And to clarify, Waterlily is actually live, right?
It's live, yeah. So if you go to waterlily.ai, you can use it in a simplified version. This is my dev environment where all the new features will be coming out in the next week, and that I'm working on at the moment. So once you click on that button with the prompt and the artist, what it does is send this to our artist attribution contract, and ask for payment. So we're only charging 0.1 fill. TFIL is our test Filecoin. I need a dev network. I can't be spending Filecoin constantly to try this out. But users would use our mainnet one, which is in Filecoin payments. So 0.1 Filecoin, a great majority of that, besides I think about 0.0002 Filecoin for gas fees, are put into the artist contract, which they can then withdraw at any point, or when it hits a certain number, we automatically send it to them. We just wanted to avoid taking out any more gas than we had to each time. So we, created every time it hits 2 Filecoin, we'll send it to them because it's not very expensive to send transactions on the Filecoin network. So what this does is it hits our artist attribution contract. That then forwards on to, let's have a look at, have I got my, yes, I do. So this is our artist attribution contract, which, like I said, if you call the stable diffusion image, this will forward onto our Lilypad events bridge. So this basically runs through here. It gets the job spec, which is our Docker job spec, which to run on Bacalhau, because Bacalhau needs, some sort of spec. It needs to know what it's running. And that sends to our Lilypad events contract, basically, or our specialized one that verifies it's the right contract. But in general, our Lilypad events contract.
Can I ask you about the job spec quickly?
Yeah.
So that was a string that was being concatenated together, right? Is it like a JSON file, basically, or a JSON string?
Yeah. So for our artist one, it's a bit harder to tell because we know exactly where we're sending it. So we're just kind of doing a mapping. But if you have a look at some of the Lilypad examples, for example, we have a stable diffusion caller example in the Lilypad's repo, and it looks like this one. Then you can see the spec just looks like, a Docker spec. This is basically how you would run a Docker project. Like, where is the image? Who's the publisher? So we do publish to estuary.tech. That's why we get an IPFS CID back in the outputs as well. The engine is Docker here, so you could run on Wasm as well. We're not verifying Noop or NoOp. I'm not sure what that is. Sometimes you read things in your head and then you say it out loud and you're like, I wonder if that is actually it.
Yeah. Having done a lot of conference speaking myself, and even like training where people are paying me to teach them things back in the day, I know many times where I'd be like, oh, I'm going to tell you what that is after the break.
Yeah.
What is Estuary again? Can you tell me?
Yeah, of course. So Estuary is a verified publisher. It's made by Outercore, the Protocol Labs Outercore engineering team. Super cool team. They're amazing. And what it does is it takes the idea is to make, storing on Filecoin super easy. So Estuary has created all these APIs and created all this backend infrastructure to make it really easy to onboard big data onto IPFS and Filecoin, and to make sure that that's retrievable as well. So they make deals with storage providers and make sure that data, they have a assurance around retrievability of that data too. So Estuary, super powerful, super cool tool. And the same team has just released Delta as well, which is aiming to be even quicker and bigger to onboard like really big data loads. So, because that has been a little bit of a pain point in our system, like has been quite tricky, but we're all working on it. It's happening. It's getting easier and easier by the day too. I've been there for just over a year now, I think. And like, it's amazing how much has come out in that time. So looking forward to seeing in a year or two as well.
Great.
Yeah, so that's Estuary. I think, and then, the job spec, like I said, just a Docker image, basically. Actually, let's check if we've got back some results. Here we go.
Oh, nice.
That's pretty good. I like them. I will have to send them out to you. Should I share these with you, Chad?
Yes, please. Oh, there's a share button. That's nice.
Yeah, there's a share button, so I can just... I'll tag you in this one.
I actually want them. So
yeah, you can go ahead and download them.
Cool.
As well.
Are they on IPFS somewhere now?
So they are on IPFS. we were having, so you've just hit our struggle point. They are on IPFS. We were having trouble having these come back in a really quick manner. So we've actually put in just temporarily a backend that saves these to a Kubernetes cluster at the moment, which is why if I click on one of these links, for example, and open image in a new tab, not that one, then you'll see it's at Waterlily cluster.world.
Okay.
But it actually, yeah, so at the moment, just to make this come back in a reasonable manner, because it takes a while first to include these blocks in the FEVM blockchain and then to run Bakuya. We're like, well, we don't want to wait another 30 seconds or so for the images to also return. So we've created this kind of just, let's make it a bit quicker for the user. We don't want them getting frustrated while we work out how to make it quicker properly.
Cool.
Turn that, but it does actually, I think if I go back through here and have a look at, actually I can have a look at the contract. So if I do go to the contract here, which I have artist attribution, and I say get image, I think the image ID, I should be able to get that from here, is 69. Well, I didn't even plan that. So it's actually a IPFS CID here that you will get returned.
Okay.
So that's what we're saving. We've just tried to make the front end load a bit quicker by putting this cheat mechanism in.
Great. And the CID is content ID for content addressing in IPFS.
That's right. Yeah, sorry. I sometimes forget that I'm so in this ecosystem that that's not obvious. But yeah, you're absolutely right. And we can look that up as well. So, for example, if I went to HTTPS, let's do a gateway, NFT storage.link. So this, I'm calling this a gateway because IPFS is a protocol, much like HTTP is a protocol, but it doesn't, it's not, obviously it's not compatible directly with the same protocol. So this gateway kind of gives us a way to interact between the two. It's a bridge.
Right.
So yeah, whoops. I must not have copied that correctly, I think. More than likely. Or, oh, that looks like my address actually, not the IPFS CID.
Yeah, your wallet.
That's the wallet address. So that's not right. Must be in there somewhere though, I imagine. Anyway, it does come back in an IPFS CID. I could dig that out. I don't know if people want to watch me like fumble around for that though.
That's the fun of live streaming.
We got the TX hatch there. Run Lilypad function. It definitely exists. So let me see if I can just get all images instead. And
all right. Are you using a VS Code plugin for interacting with a Solidity contract? What is that?
So this is remix.ethereum.org. Have you seen this before?
Oh, sorry. I thought we were still looking at VS Code. I didn't realize you'd switched to Remix.
No, sorry. This is in Remix. We do use Hardhat within our actual code to deploy things, but I often find, when you're testing or just trying things out, it's just easier just to have a look on Remix and play around with things there.
Yeah. So you're interacting with the Filecoin testnet from Remix here.
I am. I'm doing that. Yeah, good point. I'm doing that through my MetaMask wallet. So I have the Filecoin Hyperspace testnet on my Filecoin wallet. I have about 3 of them because there's a few different RPC endpoints. So I've got a few of them there. That's an old Filecoin testnet as well, and then Filecoin mainnet. So I am just setting that in my Remix browser to injected provider of MetaMask, and that automatically gets the FEM network, or the testnet in this case, from your MetaMask injected wallet here. So yeah, absolutely.
Yeah, a lot of people, when they talk about EVM compatibility, they focus on the write once, deploy on many chains aspect, but there's also the aspect of all the tooling that exists for EVM works for Filecoin too, which is
exactly. And there's been a lot of work in the background to make sure that's true, because Filecoin addresses obviously aren't naturally Ethereum addresses. So converting from F1 to F4, I know Glyph's done a lot of work in the background, not just on the nodes. So a lot of these RPC nodes are run by Glyph or Zondax. But Glyph has also done a lot of work around the wallet piece. So if you download Glyph wallet,
GLIF.
GLIF, yeah. There's someone you should maybe talk to. Like Jonathan from Glyph is a great guy.
Yeah.
Yeah, you'd probably know him already. And they've done a lot of work around it. Same with the Zondax team. So they're responsible for having Filecoin on Ledger, for example. They also have built out this whole Solidity library for the Filecoin ecosystem. So specific functions to Filecoin. So making storage bounty deals, or just things that you wouldn't necessarily get in the Ethereum ecosystem, because we're a storage network. So that's the power, that's the value proposition here, where we have kind of this functionality that doesn't really exist on necessarily other Ethereum chains. So
when you were talking about addresses, you said something that probably most people won't know, which was, you said F1, F4.
I did, yeah. So F1 is a Filecoin native address. So it starts with an F. That is a Filecoin native address. If you are on any exchange and have a look at their Filecoin address, it probably originally was an F something address. So F4 is the compatibility version of your Filecoin address for the Ethereum network. So it'll come up looking like an Ethereum wallet address, basically.
And yeah. Are the numbers version numbers? Like, was there an F2?
Yes, I think there was. I'm a bit fuzzy on whether there was an F3 though. I've actually never heard of the F3 version, but I'm sure there must have been. Either that, or they just like even numbers, or we're going with the Fibonacci sequence. I don't know. Maybe
nobody liked F3.
maybe they skipped over that one. Okay. So we were looking for all our images, because I wanted to prove that this is actually on IPFS. Right. That's where we're at.
And then I asked you a bunch of questions and lost the script again. Yeah, that's what I do.
And now I am looking for the function that will give me all of these images. That gives me image IDs. I know we have one that gives me artist IDs. Interesting. I'm actually surprised it doesn't store it. Yeah, it is the IPFS result. So struct stable diffusion image does have an IPFS result. Looks like maybe something went wrong there. Let's try just an older one and see if we get an IPFS result back. Nope. Okay, interesting. Well, we're definitely getting an IPFS result. Otherwise, this wouldn't work at all. So
right.
This is my backend, by the way. I'm logged into kind of the Backyard backend. It's just spitting out some queries here. If I ran this again, which I'm happy to, if people are interested, we'd kind of see this function query come in to Lilypad, and then Bacalao would run it, and then it says it's returning it back. And that's the part where we've kind of cheated and we're just polling from a Web2 server, but it does actually, or should actually return. So
I think we can believe that it stores an IPFS.
It definitely does. So I mean, this is definitely does. Interesting. Anyway, it might just be Remix that's actually not functioning that well either. Sometimes it does that. Either way, where are we at? Okay, cool. Got heaps of time. So when these do come back, you're able to download them, or like we did just before, share them to Twitter, which has a full view of it. You're also able to, and this is functionality I just put in and was going to live code today, but I kind of put it all in and then I got here and I'm like, well, I've done that now. I don't really want to go backwards. So this is a brand new feature. You saw it here first. To mint this as an NFT, what I've done is just create a Waterlily contract, much like I did for those Bakuyao NFTs we saw earlier in the stream. And it's just an ERC 721 contract. This is based off an Open Zeppelin contract. Nothing fancy about this. In case people don't know, one of the really interesting things about NFTs is it's really only the transaction that's stored on chain. You can store the data on chain. So the metadata for an NFT is kind of a separate feature. I actually think I have a slide for that might explain what I'm trying to say a little bit better here. Yeah. So even Open Zeppelin, it says itself kind of tells you this is kind of the metadata for a token URI. So for any NFT, it has this metadata associated with it. And this is usually what you think of as the actual NFT. This is your music file, or this is your image file, or, you know, whatever else it is that you've created an NFT of. And a lot of the early NFTs were just using kind of this image address that was on HTTP. And the funny thing about that was, I mean, it's a HTTP address. It's a location address that's changeable by whoever owns that, or, you know, subject to whether that person pays, you know, for their server bills, basically. Or
the domain name registration.
Exactly. So one of the big things that was happening was this is really ruggable, and this is why IPFS is really valuable for NFTs as well, because this is something you could store on chain, but, you know, you're looking at bigger files. Again, big blockchains aren't really good for storage necessarily, unless they've been deliberately made for storage, like Filecoin. But you don't really want to store these things on chain generally, because it just gets too big and expensive. So what do you do here? And the answer really is IPFS, because of that content addressing piece. So you can't change an IPFS CID. If you had a image and you turned it into an IPFS content ID, CID, and then you changed one pixel of that image and hashed it into IPFS again, the CID would be different, which means you can, you know, guarantee that whatever you get back is the actual original NFT content.
So the content ID is actually a cryptographic hash of the content, and that's what content addressing is about, right?
Yeah, exactly. And that's one of the, you know, when I first came to this ecosystem, I was just like, wow, that's so simple, but also just like so crazy in what it can accomplish, because then you can have decentralized storage, then you can have, you know, decentralized systems. You don't have to care where this data is coming from when you know it's what you want. So it was like really mind-bending for me, I guess. I was like in the next avatar.
Well, it's one of those things, as an investor, I always say the best ideas are the ones where you go, why didn't that already happen? Why that's so obvious. And that's how I felt when I learned about IPFS and content addressing too. Like, wow, okay, we should have been doing this from the beginning. Now, it's not very human browsable or readable. It's hard to memorize long hashes, but obviously you don't use it in that way. But
yeah, definitely. And look, I think we can have a naming system over the top of that as well. I mean, this is just underlying infrastructure. There's no reason you don't add layers to that and make it more user-friendly in the future as well. But anyway, this is one of the reasons, like, it's super important for NFTs as well, because this data, unless you've coded in that you want it to be dynamic or you want it to change, shouldn't change. Like, if you buy an NFT, you don't want that changing. So yeah, and one of the systems to be able to do this really well, and not just store it on IPFS, but also store it on Filecoin as well. So then make a permanent storage deal on Filecoin. And before you ask, maybe what IPFS and Filecoin are two separate projects. IPFS is just a protocol; it's not a blockchain protocol, much like HTTP. Filecoin is a persistent storage layer that uses these crypto economic incentives to keep your data stored permanently, or as permanently as you want it to be stored. So you can make storage deals for a certain amount of time. It has a market economic system, which should keep costs low, you know, kind of forever. Because, you know, the more people want to store, then the more storage providers are going to be interested in signing up to get a piece of that. And, you know, that's how market dynamics should technically work. But people smarter than me have designed those mechanisms, so I'll just give the overview.
For sure.
But yeah, so IPFS, it doesn't guarantee persistence. So it's like, I guess the best correlation for me is a torrent site, right? You know, if you go there, older pieces of content, you can't find them, you can't retrieve them, you can't get them. And that happens on IPFS too. So if you've got an IPFS CID, why are other nodes, and by the way, you can run your own node on your desktop laptop, but why are other people going to store this IPFS CID for you? Do they just like you? Like, this is one of the problems, one of the problems of the original internet too. And so, eventually this CID kind of, even though it never changes and it's still there, it's not retrievable anymore because there's no nodes hosting it. So there's ways around this. One of them is pinning, which you can do through like central entities. You can pin to their nodes. Again, though, I mean, the point wasn't to make another centralized internet. So this is where Filecoin comes into the equation. Like, let's store that CID permanent or persistently on Filecoin to keep that persistence guarantee around what we're doing. And that's how they work together. But IPFS works with other things as well. You can store it on cloud, you can store it on other decentralized networks. It's protocol, it's agnostic. So it works in many different places. You don't have to like blockchain even to like IPFS, which is, I think, really cool too. Where were we? Doing an NFT contract or something like that?
Yes.
We got distracted. I don't know how much time we have. Yes. So one of the ways to store on IPFS and Filecoin really easily is a project called NFT.storage, which has like JavaScript and Go SDKs. And basically you can just integrate that into whatever you're building. I'm building on TypeScript here. So what I've done is create a, and I'll just have a look at this. So what I've done is create NFT metadata for my NFT object, which is basically the only three things you really need for NFT metadata: a name, description, and an image link, or blob in this case.
Quick interruption. This is the code for the web application, right?
It is, yes. Sorry.
And is this back-end code or front-end code that we're looking at?
This is all front-end code.
Oh, okay, cool.
Yep, I'm running this completely on the front end. It doesn't actually have a back end at all other than Bakuyow and the Solidity contracts. There is no database here apart from I do pull the artists from a Google Sheet at the moment, which isn't a good solution, but we did this in a very short amount of time. And it works, right? Working first.
You're using a Google Sheet as a database.
Yes, basically.
Wow, cool.
We will be transitioning off that now that we've built this automation platform. But at the time, it was just like we needed, it was that or a JSON file in the front end just to get this out. But yeah, we're working on things. Working first, right? Then you improve and iterate.
Yeah.
So yes, this is all completely in this TypeScript Next.js front end. And all of this code is like open source and available. You can have a look at it under Bakuyow project /Waterlily. Yeah, so you just create this NFT metadata, which is just a JSON object. You can add whatever you like in there. You could add all the artist details if you wanted to. You can add, I'm putting a minted by function in, so you can add the original minter's wallet address if you wanted to. And then I just saved to NFT.storage. Super easy. You just connect to the client with your API key. You've got an NFT storage client, and then you send through the data. So await NFT.storage, NFT storage.client.store with that NFT JSON file, and it will return a metadata link to you. So we can kind of check that on the front end if you like as well. So if I click, which one of these are your favorites, Chad?
I think the far left is my favorite.
Far left. I like it. Okay. Let's mint this one as an NFT.
Like kind of weird eyes or a brain at the end of
it. I don't know what, maybe baby jellyfish.
Oh yeah, maybe.
Could be alien jellyfish. They are kind of alien, actually. So you can see here, like the NFT metadata has successfully been saved to nft.storage, and it's even given me a link to that metadata. So I can kind of click on this and open it up, except that I'm in Chrome here, so it doesn't recognize this link like Brave does.
Yeah, speaking of which, you said you can run a local IPFS node on your desktop or laptop if you want. And last time I checked, you can actually just start it up in Brave and it will run a node, right? That's sort of how the implementation works.
Interesting. I have not tried that, actually. I do have the IPFS extension on Chrome, but I haven't tried running a node in Brave, but that is very cool.
Yeah, I think that gives you the ability to natively talk to IPFS versus have it automatically translate to gateways.
Wow. Ah, God, they're clever. I bet that was Dietrich working his magic with the Brave crew as well, who are also awesome. But no, that's amazing. So it's created this NFT. Here it is here, IPFS, like there's your CID. This is probably very hard to read there, but and then it's going through that HTTP link because I'm not running a local IPFS node. And this is the full metadata that I just saved here. So if I wanted to just see the image, I could pick out of here the image CID and have a look at that also. So I'll just, this is the blob version, which we might not want.
Do you just remove /blob from the end?
Yeah, it doesn't matter anyway. There we go. So that's it, saved on IPFS and Filecoin by nft.storage for you in just like a couple of lines of code. So the next thing I have to do is actually approve the NFT because it's waiting for me to approve the wallet, which is on the other screen here. So I've just got to approve the transaction, and that will send through to the Waterlily NFT contract and mint this with the details, like with that metadata IPFS CID that we just created. So if I go back to Remix, sorry about all the flicking of screens there. If we go back to Remix, we've got a mint Waterlily NFT. It just by the owner, whoever owner's wallet address this is, and then a string memory IPFS URI, because that's what we want to attach as the metadata for this NFT. So it basically just mints with the owner's address and the ID of the token. So every NFT has a token ID. In this case, it's just a counter, 1, 2, 3, 4, 5, like, and no limits on how many can be made here. And then we set the token URI with this IPFS URI. And then, we do a few other things to make it easier to get these NFTs back off our contract. And that's really all there is to making this NFT. So, you know what? I think congratulations, Chad. You're the first jellyfish NFT on Hyperspace, probably. I'd hazard a guess.
All right. And the contract we were just looking at is just like a vanilla NFT contract, right?
Yes, we can have a look through it. I'll just even, is this my others?
Yeah, nothing Filecoin related, nothing.
It's honestly an ERC 721 contract straight from Open Zeppelin, which I've added a bit of functionality to. So, for example, I've got a structure for NFTs, which has the address owner and token URI and token ID, just so I can fetch it back. I've got an event being emitted every time one of these is minted. So I've added that functionality, a mapping of user's address to their NFT. And if you remember back to that Backyard NFT stable diffusion contract front end we looked at first, it was coming back with a user's NFTs, and this is how I'm doing that. I'm able to map from whatever a wallet address through MetaMask or other is connected through to what NFTs they own, and that's how I'm displaying those, just using this mapping here. The event we kind of spoke about, so I can check the new events coming in whenever I want on the front end as well. And then, it's just an ERC 721 called Waterlily NFTs. It's got this mint Waterlily function. You don't even need that. I mean, if you don't want to add all this other special functionality that I put in there, the only two things that you really need to know are mint and setting that token URI, that IPFS address, and then, incrementing to the next token so the next person can mint an NFT. Really super simple contract, nothing special, nothing Filecoin. Yeah.
And something anyone who does Solidity development would instantly recognize and know how to deal with, right?
100%. Yep, exactly. Have a look at the OpenZeppelin documents. The only difference is deploying this to a different network, really. That's the only difference here. So instead of deploying to Ethereum, we're deploying to the Filecoin mainnet.
Mm-hmm. So a couple of closing questions for you as we're getting close to the end of our time.
Sounds good.
One, I just wanted to reiterate the layers that we talked about. So you have the FVM/FEVM, which is compute over state. Then you have Bacalhau, which is this off-chain thing that does computation, which is, not blockchain-y at all, I guess.
No, it's not blockchain at all either. Yep.
Is it Lilypad that connects those two together so you can call
exactly.
from the contracts?
So this is a different slide. So have I got it on this one, I wonder? Yeah, so Lilypad is just a basic bridge contract between the two, which clearly I usually have a slide that has so I was just searching for, because usually I have a slide that connects kind of this on-chain piece, computation over state, with off-chain, and it says Lilypad. And that would have been a way better visual for explaining that. So, but you're exactly right. That's exactly what's happening here. And it's not limited to just doing this stable diffusion example that I've done here either. Like, there is a bunch of different things that you can do and have a look at in the docs as well. So, I mean, data engineering, like there's an Ethereum blockchain analysis one there if that interests you. There's, there's so many things you can do with this. If you can create a Docker image and, it runs, then molecular dynamics, we're working with people in the decentralized science field or with academics, or I think there was even someone working on, what's it called? The DNA pieces and connecting them using Bacalhau. It was a really interesting use case, but I can't think of the exact word. But yeah, you can do all sorts. You can compute all sorts of things over here. It's actually kind of an edge compute system as well, because it lives where the data lives. It's actually more efficient than some of your traditional cloud systems as well. So yeah,
great. Well, what should people do now that they've seen this high level thing?
Well, try it out, I guess. So if you're interested, have a go. I have a full tutorial on that Bacalhau NFTs if you just want to learn how to interact with the two or to build your script. So this has pretty much got everything in it. It's got a little bit about what Stable Diffusion is, then how you make the Python script, then how to build the Solidity like NFT contract. So if there's any piece of this that was kind of missing for you, this might be a good first tutorial to start on. I've even got how to connect it with the front end contract on this tutorial. And this is just up at developerally.com, which links to my hash node. And you can find this. It's also on Hackanoon, but that's probably the easiest one to remember, developerally.com, and it'll come straight up.
Super. Well, thank you so much for walking everyone through this. I'm looking forward to playing with it myself now.
Definitely. I would love that. Tell us what you build.
Yeah.
Maybe some good ones.
What I build will be so bad that I won't show you probably, but maybe I'll have a moment of inspiration. I'm less of a programmer than I used to be, although I'm more of a programmer wannabe these days.
I know the feeling sometimes. Spend a lot of time like talking and then not a lot of time programming. It's a fine balance, but yeah.
Indeed, yes.
I really appreciate your time, Chad. It's been awesome, and loved speaking with you. Thank you so much.
Likewise, thank you.